There's a reason in the last lesson I didn't say these rules are easy. I said they're straightforward, but elements like the transition metals have a tendency to make things tricky, just like they did back when we talked about periodic trends. Transition metals, one of the things that makes them a little goofy, we said that they're really unpredictable. I told you they're like the teenagers, the adolescents of the periodic table. Well, the reason they're unpredictable is because most of them have multiple oxidation numbers. The group 1 and group 2 metals don't. Group 1 has an oxidation number of positive 1. It's a rule. Group 2 is positive 2. But the transition metals tend to have multiple choices, multiple oxidation numbers. So when we're naming them and when we're coming up with their formulas, we have to make sure we know which oxidation number, which version of that transition metal we're using. And we're going to uh, delineate that with a Roman numeral. That's how we tell. And the Roman numeral comes in parentheses after the element symbol. We call this the stock system. So when you see on an exam, use the stock system to come up with the proper name for the following compound, just means that there's a transition metal involved and you're going to need to assign a Roman numeral to indicate which oxidation number it has. The example we use in this case is cobalt chloride. And if you look, cobalt has two possible oxidation numbers, positive 2 and positive 3. So if you see the formula here with cobalt and 2 chlorines, the chlorine, as a general rule, its oxidation number is usually -1, and that's the oxidation number it's going to take here because it's paired with a metal, which is always going to be positive. So you're going to choose the negative oxidation number for chlorine. If you have 2 chlorines at -1 each, that means there's a -2 total. We know this has to add up to 0, which means the cobalt has to be positive 2. That means the name of this compound is cobalt 2 chloride. It's important to understand this 2 does not mean the second oxidation number. The 2 literally means +2. All right, and it's not which number in the list, it's the actual oxidation number itself. So Roman numeral 2 in this case means +2. We'll look at the other example for cobalt chloride. You see cobalt here combined with 3 chlorines. The chlorine's a -1. We already explained why. If there's 3 of them, that means, that you've got a -3 here. We know that they have to add up to 0, which means the cobalt must be +3. Right? That's one of the choices. So we're okay. And we go ahead and name this cobalt 3 chloride. What you see is there isn't a third number. All right? There are not 3 numbers, 3 oxidation numbers total. It's not referring to which number in the list. It's referring to cobalt that has a +3 charge. So what I want you to do now, go ahead and practice with the zinc oxide. Here's your transition metal, transition metal, transition metal, and go ahead and write the formulas for each of those examples.